Hi everyone, welcome to this new tutorial. Today I'll teach you how to implement sprite animations in JavaScript using only the HTML Canvas API. That means we're not going to use any libraries, so we're going to have to implement our own animation system. So let's get started. So we're going to just animate those two sprites here that you see on the screen. So I'm going to use my editor called VS Code. It's the editor I use. And I'm going to need the extension called live server, which will allow us to have a server that we can, a local host server that we can use for our project. In addition to that, I created already the assets folders, which contains two sprite sheets. So a sprite sheet is an image that contains all the frames of the animation you want to display. So here you're going to find those animations, those sprite sheet in the description. So let's get started. I'm going to create an index.html file, which is going to be the entry point of our project, and I'm just going to use the boilerplate here. Then I'm going to name this as sprite anims. Then here in the script tag, I'm going to import I'm going to set up our script tag so we can, So if I do this, I'm going to pass in the source as, let's create a source folder .main.js. So this folder doesn't exist yet. I'm going to create it. I'm going to call it source src and then inside of that, I'm going to create a main.js file. In addition, we're going to need a utils.js file to store commonly reused functions. Then here in index.html, I'm going to specify that I want to defer the loading of the script until the whole page is loaded so we can have access to the canvas element, etc. I'm also going to specify the type as being module so that I can use import the JavaScript import syntax instead of having to import all of my JavaScript scripts as script tags in the HTML. So I can use within JavaScript, import from, etc. So now that we have that for our HTML, I'm going to, actually before that, let's create our style.css. I'm going to just write some logic to make sure that the canvas scales responsively, not responsively, but scales according to the screen with while maintaining the aspect ratio. So something like that. It maintains the aspect ratio. That's very, very important, I think, to implement. So here in the style.css, I'm going to first link it. And to do that, I'm going to create a link tag and specify the rel as style sheet and the href as style.css. And finally, I'm going to pass in that's it actually, and then close. So now we have everything we need. Now in the body, I'm going to create a div, which is going to be our canvas container, and we're going to apply some CSS to it later on for it to make our canvas scalable. So I'm going to create a canvas element. I'm going to create an ID for it. I'm going to call it game canvas. Now I'm going to also specify the width. So let's go with full HD, so 1920. And for the height, let's go with 1080. Now in main.js, let's actually create our canvas and just color it a certain, let's color it a certain color. So I'm going to create another file. I'm going to call it canvas context, and it's going to contain a constant that we were going to export in all of our files so that we can use that. We're going to export it here so we can use it in other files, and it's just going to contain the context to the Canvas API. So in order for us to be able to use the default Canvas API to draw things in the HTML Canvas element, we need to have this context. The way you get it is first I declare a constant called canvas, and I'm going to get the canvas element from the HTML. So I'm going to do document.getElement by ID, and the ID is game canvas that we set here. So I'm going to put game canvas, and then here I'm going to create a constant called C for it, because we're going to call methods related to the canvas API a lot. So I'm just going to use a one-letter constant as to make things less verbose and annoying to write. And here you can get the context by calling the getContext method on the canvas element and specifying that you want the 2D context, because you can specify WebGL instead, and this is not this is out of the scope of our project here. And then finally, I'm just going to add the export keyword here to export on, so that we can use the context outside of the canvas context.js file. Now in main.js, I'm going to create my canvas. Actually, I'm going to color it something. So I'm going to first use a function called main. I'm going to set it to async. This is going to be useful when we're going to load our assets. That's why it's async. But for now, let's leave it like that, empty. And then I'm going to have main.js, call main right below. And then what I'm going to do now is I'm going to first need to do a image smooth enabled and set it to false so that we can have sharp pixel art. I'm then going to, you know what? Let's create our game loop. So I'm going to create our game loop. So I'm going to do a function game loop. And this game loop function is going to take a timestamp as the first param, and this value is going to be provided by something called request animation frame. So if you're not familiar with a game loop, is a loop that runs 60 times per second if your frame rate is 60 FPS, and it is used in game development to run logic related to your game so that you can update things. So here the way we use it is first I create my game loop and then I pass it to the request animation frame. This is something provided by JavaScript itself. And by passing the function definition to it, it's going to make sure to pass the timestamp. And the reason we need the timestamp is because we need to compute what we call delta time, which is the time elapsed between the current frame and the previous frame. And this is necessary because we want the way things move in our game, for example, moving an object from point A to point B, to be consistent regardless of the frame rate. So we want our game to be frame rate independent. That means someone who runs the game at 30 FPS versus someone who runs the game at 60 FPS, we want, if they move the character from point A to point B, to arrive to the B point at the same time, regardless of how many frames there are. By default, if you were to just add a value inside of the game loop to move an object, for example, then the one with the higher frame rate would move faster, and we don't want that. So I'm going to create outside of our game loop a constant variable called dt, which is going to stand for delta time. Initially, we don't need to define it, so I'm going to just leave it as is. Then I'm going to create another variable, call it old timestamp. This is just to store the time, the old timestamp, so of the previous frame. Initially, at first it's 0. And then I'm going to also have a FPS variable, so we can display the FPS in a moment. So this is all ground up work in order to be able to implement animations. So let's do that. I'm going to, in my game loop, set the delta time to being the current timestamp minus the old timestamp divided by 1000, which initially we have this in milliseconds, the timestamps. By dividing it by 1000, we get the delta time in seconds. And that means it's going to be much more easier to compute the FPS. So here I'm going to store the old timestamp as being the current timestamp, because remember, old timestamp is going to be used in the next frame. So by storing the current timestamp as being the old timestamp, you're storing it for the next iteration of the loop. Then I'm going to compute the FPS by doing math.round. So it's going to round the value between 1/delta time. And this will gives us the FPS. And now one thing you need to do, and it's going to be apparent in a moment, is that if you ever worked with the Canvas API and you had an animation like this and you would switch tab and sometime later come back to this tab, you would for a moment see the animation running faster than it should, as if the canvas is trying to catch up to the time where the frames weren't rendered, because by default when you switch a tab, you open up a new tab, it's pausing your game loop in a sense. So that's why it's doing this. And to prevent this, the trick is to have an if statement that guards your update logic and rendering logic. And what you need to do is, if the FPS is superior or equal, to only run basically the logic for the game loop, if the FPS is superior or equal to, let's say, a target or minimum min frame rate. And that min frame rate, we can define it here, for example. It can be a constant because we only modified once. It can be 5 FPS, as long as it's something bigger than, I think, yeah, 5 is basically almost the minimum that you can use for it to actually be effective. I don't know exactly why, but it seems to work. Now I'm going to draw first I'm going to call the clear rectangle method from the Canvas API. This will clear whatever was drawn before on the canvas, and this is how we can refresh our canvas so that we can change the content every frame. And the way you use clear rect is you specify basically a rectangle area in which everything will be cleared. And here in this example, you select as the first two param the x and y coordinates. Things in HTML canvas are drawn from their top left corner. That means that if you set the position as 0, 0, that corresponds to the top left corner of your canvas. And then you specify the width and the height of that rectangle, of that area, and it's going to be the canvas width. And we don't have access to the canvas width here. That's why in the canvas context, I'm just going to export that as well, so that we can have access to the width and the height of the canvas. So here I can do canvas.width if after importing, by the way, I did not do the imports. So I need to import C for the context and canvas from, and then here it's going to be the canvas ctx, so for context.js. And now I have the canvas width, canvas height, and that's it. And then now I'm going to color the canvas a certain color. So I'm going to do c.fill style, and the color I'm going to pick is going to be hashtag f6 f6db. And then to actually draw something on the screen, draw a rectangle on the screen, you can use the fill rect to draw a filled rectangle. Again, you specify as the first two param the x and y coordinates of where you want to place it. We want to place it from the top left corner. Since the rectangle is drawn from the top left corner, it's going to basically cover the whole canvas. And then for the width and the height, I'm just going to do canvas.width and canvas.height, so it covers everything. Now let's look at the result. So as I mentioned earlier on, I had the live server extension installed on my machine. I recommend that you do too. If you do so, in VS Code, you can find down below a Go Live button. If you click that button, it's going to open up a local web server of your thing, and then it's loading. And then I have an issue. So the issue is that I did not specify the path correctly. So let's do that. I'm going to go here and do / so that it is a path. a valid path. And now things are still not working. Why is that? Did I do thing? Actually, I did not do the proper. The game loop isn't running. So the way the game loop works is that you pass it to request animation frame, but the game loop itself needs to call itself the request animation frame. So you need to call it within again and pass in game loop. So it's recursive in that sense. So it's calling itself at the end of itself. That means it becomes a loop. So now if I go back and look at the result, we can see that our canvas is fully colored. Now the canvas is a bit too big, and this is the perfect time to work on the CSS for it. So for the CSS, the way I'm going to go about it is I'm going to specify a root pseudo selector, and in it I'm going to specify my CSS variables, and I'm going to specify the width as these need to be the same width and height you put in the HTML tag so that we can have our container scale accordingly. And then here I'm going to have some CSS for the body and HTML to take a width of 100%, so it takes the whole canvas, the whole page, sorry, and a height, actually it's and a height of 100% as well. Then I'm going to set the position to being relative. So this isn't a course on CSS, but I'm just going to write this out. So we have our body and then margin 0. And then here for our game canvas, I'm going to set the image rendering to pixelated. And this is very important if you want to have sharp pixel art. So not only do you need this to have image rendering pixelated, but you also need to have added the image smooth enabled false, set it to false. And then here is the actually cool stuff that does the responsive things, is creating a class called container. And then here I'm just going to add that class to our div here. It could have been an ID, it doesn't matter. So here I'm going to use the position absolute so that we can position our container using X and Y coordinates, kind of. You can specify the top and left, and those act as our X and Y coordinate. So top is basically our Y coordinate. So I'm going to put 50% here, and then left 50%. And the reason we're going to do that is going to be apparent. Now for the width of our container, it's going to calculate. So I'm going to use the calc function in CSS, and I'm going to take the variable, the value of the width variable we declared, and multiply it by 1 pixel. And then I'm going to do the exact same thing for the height, so 1 pixel. Now I'm going to have a transform. So before doing any of that, let's actually declare something in our JavaScript. So let me look at the result. So for now we have this like that, and nothing is really scaling. So I'm going to explain in a moment. So in our main.js, before at the top, before even the main function, we're going to write logic to declare a scaling variable. So the way it's going to work is, if you noticed in the HTML canvas, we have this point. So what we're essentially doing is we're taking our canvas and centering it here. So it doesn't look really centered for now. For now it doesn't. So if I close this, you can see mostly centered this, and then by translating it by 50% to the left and 50% on top, it's going to put it at the correct position. And this is going to make sure that we don't need to actually know the final width and height that we need for the window, etc. So that's a trick, a CSS trick. Now, I'm not the biggest expert on CSS, so that's it's a lot of trial and error. So for me, so I'm gonna use the container here, and I'm gonna get the container element by using query selector all, and I'm just gonna call it container like that to get the container. Don't forget the dot. Now I'm going to use a new resize observer. By the way, I think you could have decided to just have a window on resize. I think that's the on resize, and then define some logic here. And then here you would use document element style set property. What this does, it allows us to create a CSS variable within JavaScript. And I'm going to create the scale CSS variable, and we're going to use it. And here we're going to compute by how much we need to scale our canvas. And it's going to be the minimum between the container parent element. So that's the body. And we take element, and then we take the offset width. We divide it by the container offset width. Okay, so the reason we're using offset width is because it contains everything, including the padding, the border, the scroll bars, etc. Instead of just using client width. So we have the whole thing. And then I'm going to divide it by offset width here. And then it's going to be either this. Actually, I don't need to have a parenthesis here. And then it's either the minimum between this and the offset height divided by the container offset height. And there is an issue. I did not close properly. All right. Now that we have that, I think we're ready to just look at the result. And we have nothing that works yet because we haven't used the transform in our container CSS code. So here what I'm going to do is call the transform, use the transform property and use the translate, and then translate by -50%, -50% as I explained, so that we can be at the top left corner. So if I look at the result here, you can see that we are going to be at the top left corner. And now if I open the console, yeah, it's not very visible anyway. So I'm going to add the scale function, CSS function, and then pass in the scale variable. So the way I'm going to do this is var and then scale, and then we can have a default value if scale is not defined. Initially it isn't, and it's only when the JavaScript runs that we create that variable. That way we can define a default value here by default here. Now if I look at the result, we can see that everything scales nicely, and we're ready to work on our logic for the animations. All right, so now let's work on the rest. So in main.js and in our game loop, after having defined the thing here, so let's have a debug mode. So a debug mode is just going to display our FPS counter. So I'm just going to declare a constant called debug mode. I'm going to set it here, and it's just going to allow us to toggle when to show the FPS counter. And so to display the FPS counter, I'm going to set the font we want to use as a 128 pixel Arial font. And then I'm going to set the fill style as being black. And I'm going to set the fill text as being the FPS and at position 25, 120. And if I look at the result, fill text is not defined. That's because I had a typo error. And we have our frame rate that appears at the top left corner. All right, So now let's write our logic to load our images. So in the utils.js file, I'm going to create the following. So I'm going to create a exportable function. I'm going to call it load sprite and pass as set the param as the source. And then I'm going to return a new promise. So for loading images, I think it's best to use a promise, which takes in a function and pass to it the resolve and reject callbacks. And here I'm going to declare my constant image and use the image constructor to basically create a HTML image. And then I'm going to set the source as being the source passed, and I'm going to add a cache busting string so that it always loads the image, because if you don't do that, at some point after running your game a lot, yeah, you're gonna realize that your browser will prevent the loading of images, and this is not something you want. It's going to cache it and then prevent from loading it, and then your code will crash and you won't know why. So here, to have a cache busting string, you just, for example, get the current time and add it to a fake param here that you just made up, and it should work. And then here, when the image loads, I'm going to use the default image onload function. I'm going to redefine it and then call when it happens. It's going to be called, and I'm going to call the resolve and pass to it the image. So resolve is something offered by the premise and the promise, and then you can pass to it the resulting value you want to pass. And then image on error is the same thing, but when an error occurs, and in that case we want to call the reject function and pass in the error. So we actually need an error object here. All right, so now we have our function to load images. I think we can start loading them in main.js. I'm going to create a const for our first sprite sheet. I'm going to call it cavalier one sprite sheet, and I'm going to use await and then call load sprite from our utils. So at the top of the file, it should be imported. And once you have that, pass the source. So the source is going to be /assets/ and then the name of the file. It's going to be cavalier anims1.png. And we're going to do the exact same thing for the other one. So because we're using async await, the code will not proceed on until we have loaded the images so until then, the rest of the code will not execute. So that's why it's handy, because it's very easy to understand. So here for the second sprite sheet, I'm just going to replace 1 with 2, and then here as well. Okay, so we have that, and that looks good. Now let's also set as a constant, I could do this here, constant, the tile size. So if we look at our sprite sheet, you can see that the way they're structured is that we have a couple of frames, and they are contained in 80 by 80 grids. How I know that? Because I made the sprite sheet and I had to find a way to make every frame fit. And the way I found is to put all frames at the top, at the left corner, and then leave a space enough for that all the other frames could fit in as well. So it's an 80, so each image in this file is an 80 by 80 frame. So I'm going to store that as the tile size. So now we need to actually generate the frame positions. So in order to know where each frame is in our sprite sheet, let's write a function in utils.js which will take care of that. So I'm going to write an exportable function in utils.js. I'm going to call it export function generate frames pause in sprite sheet. And the way it's going to generate that is we actually don't need the sprite sheet. We only need to know a few things. So we need to know the number of columns, so number of calls, number of rows, and the frame size. And the way we're gonna know all of this is if I look at the example. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows, 10 columns, sorry, like that if you look at them in this way, and 4 rows. And each of those frames is 80 by 80. So that means here, number of columns is going to be 10, 4, and the frame size is going to be 80. So inside of this function, I'm going to declare a frames pause array, which will hold the positions of each frame. Then I'm going to declare a variable called current tile x and initially set it to 0. It's the current position of the tile. So the tile here in this case is the frame. I should probably name this current frame x instead. And then let current frame y, and then this is also equal to 0 initially. And then we're going to have a for loop, and then for let I equal 0, I is inferior to the number of rows, I plus plus. In that case, we're going to have another if statement, not if statement, for loop, and it's going to have the same structure but for number of columns. And here I'm going to take my array of frames pause, and push to it an object with x being the current frame x and y being the current frame y. Those are going to be the properties we need. And now for every time we pass through the columns, what we do is we do here the following. So we're going to add to our current frame x a frame size worth of value of increment. The reason we're doing this is initially, if you look at the sprite sheet, we start at 0, 0, then we add, for each iteration of the for loop, we add 80 to go to the next frame. So the second frame's position is 80, 0. And then it's always by the top left corner that we determine the position of the frame, because we're going to cut out the rest from that origin. So that's something to keep in mind. So current frame x, and then here for each of our rows, so every time, so initially we enter our first row, so that's why we were here initially, and then we do every column, and then for every time we go for a cell in that column, we increment by the frame size, and then as soon as we're done with going through all of the columns in the row, we're going to go to the next row, and to go to the next row we need to add the y value instead of the x value. So current frame x plus equal the frame size, and then outside of the for loop that iterates through each columns in the single row, at the end of iterating through the row, we can do current tile frame x set to 0, so we go back to the beginning. So we go back. So basically it's doing, look at my plus sign. If you can see it, my cursor. We go from left to right, and then we go back to the left, and then go down. So that's why we set it back to 0, because the 0 is here. Now we do current frame y plus equal and then we add a frame size so that we can go to the next row. And then finally, after doing all of that, we're going to be able to just return the frames position. And this is what we need. So now if I go back to main.js, I'm going to integrate that. So I'm going to do, you know what, I'm not sure where to put it. So let's create our first hereafter. You know what, let's put this at the top here. And then we're going to simply put it here, create a constant called Cavalier one frame position, and it's going to be from generate frame pos in sprite sheet, and we're going to have 10 columns and 4 rows, and everything is of the tile size, which is 80. And maybe I should call this frame size instead. And here we go. So that's basically it for now. And we are ready to define our animations. We're gonna have to write some logic for every animation to actually play that animation. But for now, let's go to main.js. Let's define our first animation. And the way I want to design the API, the system, is that you create an object. Let's call it Cavalier1anims. And in that object, you can specify your various animations. So it can be in a single frame, for example, the idle, and you can just pass the number of that frame. So the way my system is going to work is a bit like in Kplay, which is the library I use to make games a lot, is the first frame at the top left corner is numbered 0, and then you increment from there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So you know what, let's put the frame 30 as our idle frame. So when it's a single frame, you don't have to worry about anything. It's just displaying a single frame. Now, you probably didn't click on this video just for displaying a single frame. So for our animations with multiple frames, and here in this sprite sheet, we actually have all of this is one animation, one attack animation. So the way to display it is I'm going to create a frames property, which is going to hold an array of all the frames you want to display. So for example, if I want to display frames 0, 1, 2, I can do that. And if I want to do it out of order or in the reverse, you can just specify 2, 1, 0. But now if we have 30 frames, so I'm not going to create an array and just do 1, 2, 3 manually. That would take forever. So I'm going to create an array programmatically using array from, and then specify the length of that array. It's going to be 31 elements, because remember, we start by the index 0. That means the last frame is numbered 30, but it's actually the 31st frame. And then here, I'm going to, the way it works is you can pass a function, and it's going to map over every element of that array. So here, I don't care about the value. So I'm going to just use an underscore, which is the convention in JavaScript to do that when you don't need a param. And then for the second one, I'm just going to return it so that the element, the value in the array, is the index of that array, of that element, which corresponds nicely with the frame numbers. And then I'm going to define another property for the speed at which you want to run the animation. It's going to be a speed of 12 frames per second. And then finally, a property that is optional, where you could define if you want the animation to loop or not. And here I'm going to set it to true. So in the next part of the tutorial, it's going to be all about implementing this. So implementing this system that can take this object and display the animation properly. which animation you want to use, etc. Alright, so back in utils.js, we're going to write a new function that is going to be called make animated sprite. And this is the core of the tutorial. It's the core logic that actually does the animations, set the various animations, etc., and then plays them. So the params we're going to have for this function are going to be the following. First, we need the sprite sheet itself, because we're going to use that to display it, to display the frame in the sprite sheet. Then we need the anims object, which contains the various animations that we want. So in main.js, if you remember, it was this object. Now, after the anims is passed, we also want the frames positions, and we get this by using the generate frames pos in sprite sheet, which will assign a coordinate for each of the frames within the sprite sheet. So we can pass that as well to know where a sprite is located in the sprite sheet. Then we're going to pass the tile size, or you could call it frame size. So maybe I'm going to call it frame size, which is the width and the height. So it's the same value, because I assume that our sprite sheets are going to be sliced up in squares. So the size basically determines by how much we want to cut out from the specific position. And this is how we get the specific sprite. Then we have the pos, the object for the position where we want to put the animated sprite in the canvas. And then finally, we can pass optionally a scale. I'm going to set it to 1 by default. And this scale is what we need, in the sense that if we need to make the image bigger or smaller, we can define it here. So now what I'm going to do is I'm going to create an object within that is going to contain properties we need for the logic, but we don't want to pass to make accessible from outside of the sprite, the animated sprite. So we're going to return here an object which is going to contain methods that you can use from outside of this make animated sprite function. So this is a bit like a object-oriented programming, but without using classes. So what's in our data property is basically private variables, things you don't want to access. And what we return is methods that we can use from the outside. So you could have decided to use the class keyword, the class syntax, or you could have decided to go with this aspect. So it's up to you, really. I decided on this programming style because I think it's simpler to understand. So the properties we're going to need are a bunch. I'm not going to type them out, but I'm going to just copy and paste them here, and then I'm going to explain each of them. So we need first a property called current anim, which determines the current animation we need to play within the sprite sheet. The current anim frame index, though, this is because we pass an array of indexes in the frames property here. These frames corresponds to where to locate the number of the frame in the sprite sheet. Remember, we start with 0, 1, etc. Here, you could have decided to have an animation where you just pick the first frame of the sprite sheet and then skip to the third one, I think, or the fourth one. Yeah, the third one. So this should this is the fourth one. And then maybe go back to 1. So it's really flexible like that, where you can handpick the frames you want. And here we just passed all the frames from 0 to 31, or 30 actually, I think, if you start counting by 0, at 0. So this keeps track of which animation to play. While the current frame is going to contain so this is the current animation, the current index, so where to locate the frame in the sprite sheet. The animation timer is important. It's going to come up where we increment, so we need to play specific frames at a certain rate, because we can specify the frame rate. So if you look at here, the speed is actually the frame rate. I want the animation to run at 12 frames per second. Okay, we have the current frame, which is going to be the current frame being displayed. And the difference between the current anim frame index and the current frame, which is also an index, is that the current frame is the actual index in the sprite sheet, so frame 0, frame 1, while the current anim frame index is the index within the array you pass here. So for example, if I pass to the frames array, I want to display the first frame, the second frame, and the third frame in the sprite sheet, which are numbered 0, 1, and 2. So if you look at the sprite sheet, you get 0, 1, and 2. If I want to display that, this frames is an array which also has its own indexes for each of those elements. So here in this array, 0, the element 0 is at position 0. Okay, this is not necessarily a good example, but let's say you had 2, 3, and 4. Then 2, 3, and 4 in the sprite sheet is actually in the frames array. It's going to be the element 2 is at index 0, element 3 is at index 1, and element 4 is at index 2. So it's not the same indexes, but we need to keep track of those indexes so we can pull out from this array the number we need to actually display in the sprite sheet. So this might sound a bit abstract and hard to reason about, but as we're going to build the feature, it's going to be much more clear and you will be able to modify values. So here is two properties I added where initially I wanted to add flipping, so you could do a mirror the sprite. I thought that it would be out of scope for this tutorial, but yeah, something you can implement later on. It's a bit complicated, I would say, to implement. I did it, but if your sprite is not centered, that means that for each of those squares, imaginary squares that contains each frame, you really need to have your sprite at the center of it. Otherwise, when you flip, the position of your sprite is going to move farther. So this is going to find itself farther along, and it was a mess. So I just recommend just having the other way sprite in your sprite sheet so you don't have to deal with that. All right, so we have this. Now let's create a couple of methods that we're gonna need. Not necessarily use, for example, the set position. We can already set the position when we create the animated sprite, but in case you want to, set the position, you can specify an object as the param, which is going to be the position, and then you can first make sure that the type of x, the x coordinate, is a number, and if it isn't, which I'm writing the reverse condition, then we can throw a new error and say invalid, I don't know, invalid position coordinates, invalid position coordinates. And then here add a second condition, or if the type of y is not equal to a number. So in case you try to pass positions, the coordinates that aren't numbers, then we throw an error. That's good practice, so you know why things failed. Might make a mistake, or someone might be working with you and they don't know exactly what they expect, or just pass the wrong thing, so they get a nice message. Now we can set the position to being this, what is passed to this method, so we can update the position in this manner. The second method we're going to need is the set current anim. So it's nice to be able to play an animation, but you would want to actually set the animation you want to play. And here you would pass a name, which would be a string. Since we aren't in TypeScript, I cannot just do this, but it would be handy. So what I'm going to do is I'm going to check if the name in anim. So this is a way to check if, so this statement checks if the name you passed is in the anim's object. So the anim's object, we initially pass it as a param to make animated sprite. If it's the case, then this is true. If it's not the case, then this becomes false, and we want the reverse of that, so we use the bank sign to have this condition as true. So that in this case, what we're going to do is we're just going to throw. So here you don't actually need to have a brackets if you only have a single statement. So I'm just going to do throw new error, and then anim is not defined. And then if everything went well, then the rest of the code should run. And in that case, we're going to set the current anim as being what is passed. So anims, and then we pass the name, and then it's going to give us the data we need for that specific animation in current anim. Now, if I do, it's good practice to set the animation timer back to 0, because every time you change animation, you want to start from the beginning. Then I'm going to set the current frame to null. The reason I'm setting it to null is that if you set it to 0, it might refer to the first frame of the sprite sheet, and you might just want to just reset it to 0, because anyway, the logic we're going to write just below is going to take care of updating this value. So just a way to reset everything. Then we're going to have current frame pause, which is going to also be null. So in the current frame pause, we store the position of the current frame, so that we can pass this later to our draw function, which will draw which will take the sprite sheet, use that current frame position to know where in the sprite sheet the frame is displayed, is located, and then draw only that portion. So the last method we need is the update method, and it's going to be, I'm going to pass the delta time as I explained early on. It's very important when you're moving things around to have frame independence, so that your game works the same at different frame rates, and that one doesn't get a unfair advantage, or that when the frame rate is very low, things move slower, I guess, than a faster frame rate. So what we're gonna do is we also need this to. So that's the general use case, but in this particular case, we're gonna use the animation timer, the delta time, as a way to increment our animation timer. And then here I'm going to have an if statement, and I'm going to make sure that if the data, so the current anim, I think that's it. Yeah, if the current anim is a number, that means, because you remember, I don't know if I specified this, but I wanted to support a use case where you just want to display a single frame. And in that case, in main.js, you wouldn't need to pass, you would just pass here, idle, and then the number, rather than having to pass all of this in the case of wanting to display a single sprite. So now, if I go here, if I write data.current frame, and then data, the way we're going to update the current frame is by just passing to it the current anim, because in this particular case, the frame we want to display is the same as the animation. And yeah, so current anim, yeah, because it's the content of, so instead of having an object, we have a number. Anyway, I think you get the point. Now for the positions, we're gonna update that by, in this particular case, by doing current frame pause, and then doing data dot, no, actually using the frames pause, we passed to the make animated sprite, and then from there, we're gonna, since it's an array, we're going to simply pass the data.current frame, which is an index in that array, to know the current frame to display. And in that case, we just return early. Return early. Now, one thing I want to mention is that we return early because we're going to also have another method where it's actually going to draw the frames. So I'm going to leave it here for now, but let's continue writing all the various cases. So the second case is when you don't have a current frame specified. So this occurs when, since this update runs every frame, at one point your animation is finished, and in that case you want to go back to the beginning. So if you do data.current frame, so if you notice that the current frame, so actually no, this case is when you start a new animation, this becomes null, and when you start initially you have this as null. So this is the case at the beginning. when you're playing a new animation. So here we're going to set the data.current anim frame index as being the 0. So remember, this is 0 in the array you pass to the in the frames property, and not the index of the frame itself in the sprite sheet, which is the index in the frame pause. So maybe yeah, I think if you're still confused about this, feel free to ask a question in the comment section. I'll try to re-explain it best. And now here I'm gonna do data.current frame, and I'm gonna get the current frame by doing data.current frame. Actually, data.current anim dot frames, and then I'm gonna pass the data.current anim frame index, and this gives us the number of the frame we want to display. Now we have our third case where we have if the data.current anim frame index is superior or equal to the, so if we are at the end of the animation, so you do data.current anim.frames.length, and since frames is an array, you can do this -1, which is the actual index, so the last index of our frames array. If the current anim frame index is superior or equal to that, that means we are at the end of the animation. And we also need to check if, with an end statement, if data.current anim has the loop property set to true. In those cases, that means we are ready. That means we need to replay the animation because we want it to loop indefinitely. So in that case, I'm just going to copy and paste to go faster in that case. So let me just find a portion of code for that. All right. So we set back the anim frame index to being 0, and then we set the current frame as being the 1 from the frame index here. So basically going back to the first element of the frames array. And that's it. The last case, though, is actually the logic for, well, the default logic. So by default, what we do is we set the current frame by checking the current frame index and then setting it up like that. And then we do the following. So we have the current frame position, which is frame pause, and then we get that, the updated frames position. And this will allow us to move forward like that. So, yeah. And now you could say that we probably don't need this part. So I'm going to comment that out because we only need to set the index, and anyway, it's going to be set back here. So I'm just going to comment it out for now. And then if there are any issues, I'm going to try to understand why, and then try to fill you in on the issue, on the situation. Now we need to store the duration per frame, which will allow us how much time we need to display each frame in the animation. And to get that, the duration per frame, you multiply 1 by the speed. So data.current anim.speed. And this gives us the duration per frame. And the reason why this works is that it's for 1 second, how much we should display each frame. So for 12 FPS, stands for 12 frames per second. That means we should display for 1 second divided by those 12 images. So each image is going to have 1/12 of the time to be displayed. And then this is the logic. The last if statement we're going to have is the logic that actually updates, checks if the duration per frame is exceeded, and if, in that case, moves on to the next frame. So to achieve something like that, I'm just going to copy and paste it, and I'm going to explain the code. So here what we have is we have an animation. We check our animation timer, and if the value in the animation timer is superior or equal to the duration per frame, and the current anim frame index is inferior to the last index of the frames array, that means that we aren't yet at the last frame in the animation, and that means we can safely just increment the anim frame index in the coming from the frames array. And then by doing that, so when I say coming from the frames array, I mean that is relevant to the frames array. So we can increment that, and then we can set the current frame by doing this, and then set the animation timer as well. So actually, I think this might not be necessary as well, since we're already updating this here anyway. But we actually need to do that, and we need to subtract to the animation timer the duration per frame, so we can know, we can display the next frame and then recalculate that. So that's yes. So basically resetting the timer for the duration per frame for the next frame. All right, it's time to write the logic to draw the sprite in the sprite sheet on the canvas. So to do so, I'm going to go outside of the make animated sprite function. I'm going to declare a reusable function here called draw frame. Its role is just to draw things. And it takes as its param a sprite sheet, and then the frame position in the sprite sheet, so where the frame is located within the sprite sheet. So this coordinate object with x and y property corresponds to within the image, within the sprite sheet. Then I'm going to pass the frame size, which is the size of each of the frame you want to display, which will inform the draw frame method function by how much you want to cut out the specific position in the sprite sheet. And then the canvas position is the position on the HTML canvas, so where you want to put the animated sprite on the canvas. And then finally we have the scale, by how much you want to scale. This is by default 1, but we're going to pass it from the make animated sprite as well. And then to actually do the implement, oops, I made a huge mistake. I wrote this as the body instead of the, so let's do this properly. So now that we have our params, let's use the C from the context, which is imported at the top. Oh, it's not actually. So since I have exported globally our C canvas context, we can just use it here. Did I do that? Yeah. Actually, I don't think we used this much. Maybe we use it in main. Yeah, okay, we use it in main. That way we don't have to pass the context as a param all the time, which can get annoying. So draw frame, not draw frame. Yeah, draw image. Draw image is the actual Canvas API method function for drawing images in HTML5 canvas. You pass in as the first param the image you want to draw. Then when you want to draw a frame in an image, you need to pass the second param is going to be the position within the image. The second is the y coordinate for that. Then you need to pass the frame size, the width and the height, so it's the same in our case, so I'm going to repeat twice frame size. Then I'm going to pass the canvas positions. So the order of this is important. It's how the draw image functions. You first pass the coordinate within the sprite sheet of that frame, and then you pass the width and the height you want to cut out in that sprite sheet. And then you need to pass the canvas position, so the position where to draw the image on the HTML5 canvas. You do this again, you pass the Y, and then you do the frame size here. It's going to be the final size of the image. So I'm going to just pass the frame size and multiply it by the scale I want. By default, it's 1. And then do that twice, since we are dealing with a square, so at each frame is assumed to have the same width and height. So now we have our draw frame method ready. I can just go here and call it. So the way I'm going to call it, I'm just going to do the following. So draw frame, pass in the various things we need. So the sprite sheet, the current frame position, the tile size, which actually can be frame size. I think I called it frame size. The frame size, and yeah, actually, where it's getting the frame size from within the function. Yeah, frame size here, and then the position you want to place it, and then the scale value. So everything should be all right. Now it's time to use that, and let's use that in main.js, and then we'll be going to be able to check if there are any issues. So in main.js, what we're gonna do is we're going to first, right below, let's say here, let's declare our first sprite. Store this in a constant. I'm going to call it cavalier1 sprite, or actually cavalier sprite1, and then call the make animated sprite from utils.js. If you look at the top, it should import it. Yep, it's here. And then I'm going to pass into it the cavalier1 sprite sheet, the cavalier1 anims, and then I should probably call this cavalier1 sprite instead. And then here we're going to have the cavalier1 frame positions. And then for the frame size, I'm just going to pass in the frame size of 80. And the position, let's put this at 250 on the x-axis. And then for the y-axis, let's put this at 100. And then let's scale this 8 times for it to be clearly visible on the canvas. Otherwise, it's going to be too small. And then after creating this, I'm going to call the method, so cavalier1 sprite, set current anim, and the first anim I'm going to display, let's display the idle animation. You know what, let's go directly with the attack animation. Yeah, the attack animation. Yeah, let's go with that first. So attack. And now inside of our loop, so within the frame rate, the frame rate check, which I explained is there to prevent speed up when you switch a tab and then come back. I'm going to do cavalier, or I don't know how to pronounce this properly in English. Cavalier1 sprite, and let's call the update function and pass in the dt, delta time. And then right after that, let's call the cavalier1 sprite the draw function. So update, draw every frame. Let's look at the result. And that's strange. Okay. What is this? Why is it drawn like that? All right, so the issue is the following. So for the animations, the reason it isn't moving is because first I did idle. So if you put back attack and you go to utils.js and comment this in, so this was commented out and you need to comment it in, then it's going to work. Now the canvas is blurry and we don't want that. And the reason for that is I made a typo. I wrote inside of main.js, I wrote image smooth enabled, or it's smoothing. So image smoothing enabled. That should be set to false. Now if I look at the result, you can see that everything is nice, crisp, and clear. So let's add the second one. So for the second animation, I'm just going to copy and paste it because I think at this point we already have everything we need. So for the following, I'm going to add where we declared our first cavalier. So the second one it's going to be this way, this animation 39 from the second image, etc. Here it's frame size and not tile size. And then this should be okay. And then finally here, it's going to be the same thing, but I'm going to declare it here. And I'm going to tweak the position. Let's put this at 12,000. And then here, 1,000. And then here, let's name this Cavalier 2. And then 2, 2, 2. And then here, let's copy that again and have the second one. Here we go, 2. And then here, same thing, we can do the following. So update and draw, or you could go with update, update. So we first update everything and then we draw them. So you could go like that. And then you would have Cavalier 2 and then 2. Let's look at the result. And now we have a beautiful animation. So now we can play around. So for example, if I want to increase the frame rate, I can do this. Let's say I want this animation, the left animation, to run at 24 frames per second. And now you can see this moves much faster. If I want the animation to go back, let's say here, to move at 8 frames, it's going to move much more slower. And now if I just put this back to 12, let's use the idle animation for the first Cavalier. So here, instead of attack, it's going to be idle. It should display only 1 frame. And we have 1 frame that is displayed, which corresponds to the first frame of the sprite. So that's it. That's the tutorial. Hope you learned a lot building this animation system with only vanilla JavaScript and the HTML canvas, no libraries. If you want to see more content like that, feel free to subscribe. And one thing I want to check is this. So here, I thought that you could just have this and be okay and not need this, but it seems that we need to update this as soon as possible because I don't really understand why. So do we need this? Let's go here and refresh. And yeah, okay, it seems that that's strange, you know. No, I think we actually need this because of the case. One thing I forgot to test out is if you go here, let's say I don't want the second animation to loop. We need to check that this works. So the second animation will run and then will stop. Now, if I were to remove the code here, actually, where we update the current frame here, because it's not necessary, but it would be necessary in this case. So let's say we put that here. So in that case, let's say it will run and then at the end it stops. Okay. Now if I want it to loop, well, I should actually check the other one. Is it looping? And it is. All right. So we actually don't need the update here, but we actually need to put it back here for this specific case of looping. Otherwise, everything is covered. So that's the tutorial. Hope you learned a thing or two. If you want to see more HTML, Canvas, game dev tutorials and content, feel free to subscribe to my channel. Thanks for watching. And oh, one thing I forgot to talk about is that I have opened a Patreon where you get every video I make 24 hours in advance. You also get the access to the source code of this project, this specific one, that you can either access by supporting me on Patreon or you can buy things individually. I also have a course that you can buy on Patreon. So Patreon, it acts as both a way to support me monthly if you want, and also you can buy things in the store there. So the link will be in the description if you are interested. Thanks for watching. Bye.